Alrighty, hopefully you guys have gotten this warm-up done. So we know it's a hyperbola, it tells us that, and we want to find the coordinates of the vertices. So what we need to do is get it into the standard form for a hyperbola so we can then figure out what those vertices are from the formula. So, or from the base form. So the only thing we have to do is divide everything here by 1600. 25 divided by 1600, ironically, is 64. So that turns into 1/64th for the first fraction, or y squared over 64. And again, we just said that 25 divided by 25 goes into 1600 64 times. So then 64 goes into it 25 times. So this other fraction, x squared over 25, equal to 1. So now we have what a squared is going to be, 64, which means that a is 8, and b squared is 25, so b is 5. The b part doesn't really matter to us too much. We really want to focus on what a is here. We're going to use that to find the vertices, but we need to know that it's vertical because it's y squared first, so we know that. And that means we're going to add the a value to whatever k is for our center. And there's nothing we added or subtracted to the x and y individually, so that means our center is at the origin. So all we have to do is go from 0 and add 8, and from 0 and subtract 8. So our vertices are at 0, 8, and 0, negative 8. And that's it. Now, if it wasn't centered at the origin, it would have made things a little bit different, but we still would have been able to just add 8 and subtract 8 from the k value there. So today, we're going to take a look at how to identify which type of conic you have, given to you in a general form. And there's a couple different ways you can do that. You can start by just getting into the standard form, which is all these different forms we see here. But sometimes that can be complicated and unnecessary. So I'm going to show you how to do that first, and give you an example problem, and then we'll come back and we'll take another look at something else that's another way to do that that works for every type of conic without having to do all the work to get it into these different forms. So let's do that. So this first one actually wants us to graph it. So that's where you actually do need to get it into a format you can use to graph. So when you are going to have to graph it, then yeah, you might as well go ahead and get it into the standard form for whatever type of parabola it is. If you want to know what type of parabola it is, or what type of conic section it is. So if you want to know what type of conic section it is prior to graphing it, you can do that and use the form we're going to talk about later, but you don't have to do that unless you absolutely want to. So in this case, we're just going to go ahead and move the 2x over. So we're going to make it a positive 2x squared plus y squared equal to 18. And so we have this x squared, we have a y squared, and it's equal to 18. So right now, it could be a circle, right? But remember, circles are typically equal to something that's a whole number on the other side. So if I divide by 18 on everything, I guess it is equal to a whole number, but usually equal to something that's not or a perfect square would be beneficial. Doesn't have to be. But also, we don't have coefficients in front of our x's and y's. So the 2 in front of our x squared tells me I need to divide this 18 out. And 2 over 18 is 1/9. So we just have x squared over 9. Y squared is still over 18. And 18 over 18 is 1. So now we have it in as much of a standard form as we can. There's one thing we probably would want to change if we're going to actually get it into true standard form. We would move the y squared first. But in this case, it doesn't really matter since it is adding. But that way we know now, because y squared is first, it's a vertical. And since it's a plus in the middle, it's a vertical ellipse. So now we need to graph it. And our x's and y's are not being added or subtracted with anything, so center is at the origin. Our a is equal to the square root of 18, which is about 4.243. And our b is the square root of 9, which is 3. So going out to the x direction, 3. And going out in the y direction, that 4.24, it's about 4 1/4. Somewhere around there anyway. And now we're ready to go ahead and plot our ellipse. And it's about there. So once you are able to get it into a standard form, thankfully we have that list. We know kind of what to expect for what it looks like. Now again, we didn't have to move the y squared over, but because we have that larger number on the bottom of the y, typically with an ellipse that is first. So that's where we have to do. That's why I moved it. But you don't have to, as long as you remember that whatever is the larger number is going to be the square root of that is your a. Just got to remember that part. So now here's a practice one for you to do.